Let's graph all these shifts. So we've got our first one fixed in space. Now, y equals minus e to the x. What this is if you covered the minus out, it would just be the exact same graph, but now we're timesing all of the heights by a negative at the very end. So that's a reflection in the y-axis. So it's going to look like this. Exact same graph, just the heights are times are minused. Easy. E to the minus x. So what this is every time we used to input like 1, the function actually now reads me inputting 1 as a -1. So it evaluates itself as if this one was a -1, but now it's happening when I actually am trying to put input 1. So we can understand all these as a reflection in the y-axis. So it's going to be something like this. Identical properties. So that's your graph of y equals e to the minus x. Whenever you input a negative into the x, the functional spot, it's going to reflect it in the y-axis. Y equals e to the x minus 2. This is just the graph y equals e to the x and then shifted, bumped down by 2 everywhere. You evaluate it and then you force to -2 from the height everywhere. So instead of having an asymptote at y equals 0, you now have an asymptote at -2. You fix it in space there. Instead of going through 1 there, it goes down by 2. So it's going through -1. And it's the exact same functional graph. Y equals e to the x minus 2. Okay, how does that compare with the next one? E to the x minus 2 now. When you put something in the functional slot and you have a minus in there, that is going to be basically delaying the function by 2. Because, pretend I put in a 0 into here. It's now getting evaluated at x minus 2. So it's what this graph was, but 2 delayed, essentially. So that's why this is a rightward shift. So instead of going through the point 0, 1, it's now going to go through the point 2, 1 here. So it's a rightward shift everywhere. Counterintuitive. Minus 2, but actually going to the right. Y equals e to the 2x. This is like a very aggressive value. It equals e squared when x is 1. E squared. So this thing just skyrockets and dies very fast. You've got a scaling factor in the functional slot. That is going to be more aggressive than this one even. So this one, let's just do it in black. This takes the graph y equals e to the x and it just multiplies it by 2 everywhere. So whatever heights we were getting on the old graph, they're now bumped up by 2 times. So they'll give you something like that. This is y equals 2 to the e to the x, like a normal scaling factor. Line y equals e to the 2x, far more aggressive. So in summary, we have scaling, scaled by 2. You could say this is like functionally scaled by 2. These are always when you have a subtraction or an addition in the functional slot. These are left-right shifts. In this case, it was a rightward shift because it's counterintuitive. Always the left-right shifts are counterintuitive. This one is just a simple up-down shift. This one is a reflection in the x-axis. Sorry, reflecting the y-axis. This is a reflection in the x-axis. and